Hi students, welcome to physics class. In this video, we will discuss about dimensional analysis. Physics first year, unit 2, units and measurements. Now, let us try to understand what is dimensional analysis. Dimensional analysis is a technique to check the relationships between different physical quantities by identifying their base quantities such as length, mass, time and electric current. We know that we have 7 basic or fundamental physical quantities. These fundamental physical quantities are 7 dimensions of the physical world, in which length is represented by L, mass is represented by M and time is represented by T and electric current is represented by I or A. Thus, dimensional analysis is a technique to deduce relation among interdependent these physical quantities. Okay. Next, applications of dimensional analysis. Dimensional analysis is used to check the consistency of a given equation or formula. Next, it is used to derive relationship between physical quantities. It is used to convert one system of unit into another. That is, we can check whether the given equation is correct or not. F is equal to, let us say, ma. We can check whether the equation is correct or not, or we can derive the relationship between the physical quantities. Let us say F depends on m and F also depends on a. Then we can derive the relationship between these two physical quantities, which is dependent on the force. So, force is a physical quantity which depends on mass and a acceleration of a body. And also we can convert CGS units to SI unit. For example, the SI unit of work is joule and we can convert SI unit of work joule into CGS unit of work erg. So, we have 3 main applications. First one is to check the consistency of given equation, and second one is to derive the relationship between the physical quantity, and third one is to convert one system of units into another. Okay, right. Let us see how we can derive the equation for time period of a simple pendulum using the method of dimensional analysis. Here we will use the principle of homogeneity. The principle of homogeneity. The principle of homogeneity tells that we can add or subtract or compare the physical quantities which has same units, Now carefully read the question. Suppose that the period of oscillation of simple pendulum depends on its length, mass of the bob and acceleration due to gravity g. Derive the expression for its time period t using the method of dimensional analysis. In the question, it is given that the time period t depends on length. Let us say it depends on length, and it also depends on mass. Finally, it also depends on acceleration due to gravity g. We don't know whether the time period directly proportional to L or inversely proportional to L. In the same way, we are not aware that the time period whether depends on the mass directly proportional to mass or inversely proportional to mass. And finally, we don't know whether the acceleration due to gravity g depends on time period directly or inversely. And in the same way, we don't know the powers of L, M and G which depends on the time period. So we can say L power x, M power y and G power z. By removing the proportionality, we get the proportionality constant k into L power x, M power y and G power z. Okay. Here the dimensional formula for L is m power 0, L power 1, T power 0, and the dimensional formula for mass is m power 1, L power 0, T power 0, and the dimensional formula for acceleration due to gravity g is similar to the acceleration a, which is equal to m power 0, L power 1, T power minus 2. And the dimensional formula for time period t is equal to m power 0, L power 0, T power 1. And now by substituting these dimensional formula in the given expression, we get dimensional formula for time period is m power 0, L power 0, T power 1, which is equal to some proportionality constant k into the dimensional formula for length is m power 0, L power 1, T power 0, and the dimensional formula for mass is m power 1, L power 0, T power 0, and the dimensional formula for acceleration due to gravity is m power 0, L power 1, T power minus 2. And we have the powers x, y and z. Now by multiplying with the powers, we get k into m power 0, L power x, T power 0, m power y, L power 0, T power 0, next m power 0, L power z, T power minus 2z. Here we get m power 0, L power 0, T power 1. Next we can use the formula a power x into a power y is equal to a power x plus y. Here bases are equal, so the powers must be added when there is a multiplication operator. So we can write k into, we will multiply m terms and we add the powers, then we get m power 0 plus y plus 0. Next L terms, L power x plus 0 plus z. Next t terms, T power 0 plus 0 minus 2z. Left hand side we get m power 0, L power 0, T power 1. We know that a power x is equal to a power y. Here bases are equal, then powers must be equal, x is equal to y. In the same way, m must be, bases must be equal, so powers must be equal. So 0 is equal to 0 plus y plus 0, that implies y is equal to 0. Next by comparing L terms, we get 0 is equal to x plus 0 plus z, which implies x is equal to minus z, and by comparing t terms finally we get 1 is equal to 0 plus 0 minus 2z, which implies 2z is equal to minus 1, therefore z is equal to minus 1 by 2. Here z is equal to minus 1 by 2, then x is equal to minus of minus 1 by 2, which is equal to plus 1 by 2. So finally we get x is equal to 1 by 2, y is equal to 0, z is equal to minus 1 by 2. In the expression, t is directly proportional to L power x, m power y, g power z. Removing the proportionality, we get proportionality constant k into L power 1 by 2, m power 0, g power minus 1 by 2, which is equal to k into L power 1 by 2 divided by g power 1 by 2, which is equal to k into square root of L by g, is the expression for the time period of simple pendulum which is given in the question. The dimensional analysis only checks whether the time period depends on length, mass and acceleration due to gravity g, and it also calculates the power of dimensions, but the dimensional analysis cannot deduce the dimensional less quantities. Dimensional less quantities such as k. Actually, k is equal to 2 pi. This cannot be derived from the dimensional analysis. So finally we get the expression t is equal to 2 pi square root of L by g. The dimensional analysis can only gives the relation among the physical quantities but not the constant terms, that is the dimensional less quantities. Okay, this is the way to derive the relationship among the physical quantities based on the dimensional analysis. Okay, thank you.